Thank you for your patience. I give you Victor Palmer.
All right, thank you. So thanks for coming. Sorry for the technical difficulties that we had today. It's a Mac. What do you expect? So my talk is not really too technical. It's more about some of the journey that I've gone through in the past couple of years, from becoming more of a system administrator to more of a developer role. My name is Victor Palma. I currently work for Rackspace for the last 5.5 years. I love scuba diving, something I picked up recently, and something I am very fortunate to be here in Australia to go scuba diving after this. So I'm pretty looking forward to that. So I don't know if you guys know, but yesterday or today, when I woke up this morning, it's actually sysadmin day. So you should thank yourselves, if you're a system administrator, congratulations, happy sysadmin day. So really, with the way when I started putting this talk together, it really came about, some of the experiences that I started with. And initially, it was more of like, it felt like, computers saying no. They always had their own mind. And that really was more due to either bad code, bad hardware, or something just not working correctly, connectivity or what have you not. Hardware has gotten better, so that has gone away. But at the same time, it also increases, but you do what you can with what you have. But more importantly, as it relates to Python, not Python fortunately, but just in general, like it was more about the code that developers were handing to me as an operator, and I was actually running, executing for them. And unfortunately, most of my experiences early on was more around the developer saying they're done. It's 5 o'clock in the afternoon, they leave, and then all of a sudden I have to work the weekend because the code is bad and this stuff keeps rebooting. So that felt a lot more like developers throwing waste over the wall and just saying like, oh, it's not my problem. The eternal, it worked in my machine. I don't know why you did wrong, or what happened. So inevitably, what that ended up being is more of a repetitive task. It felt more like this, where I actually had to reboot a machine or write scripts to say, if the memory reaches this level, then go ahead and reboot the machine, because that was the only fix for it. Fortunately for us, here, we're safe now because now we have DevOps. It's going to solve all the things, and it's going to fix everything. That's kind of like a lie, but it's really more or less how the evolution as a system administrator has gone now to become more of a developer role, especially today when we deal with tools like Ansible, Salt, that are Python-based. We end up getting more into the realm of programming. What does that look like? In Salt is the salt states, the formulas, etc., which inevitably goes into us becoming more about programmers and thinking about how we do things. What it really means is that as programmers or developers and system operators, at the end of the day, it's just same coin, two different faces. As developers, we focus more on features, which features equals change, which equals instability. As systems operators, we care about the opposite. We really don't want to change things if they're working, mainly because changes equals a risk for failure, and because we want to make sure those systems stay up, because that's our responsibility. It's really, it's really challenging. As I mentioned before, the becoming a developer has been more of an evolution. You could think of, I started as a tater tot when I first started working with system administrator. I did that for a very long time, and eventually I grew into doing more operations. So you could say I became Mr. Potato Head. Just like any system administrator, it takes time to become a programmer, a good programmer for that matter. Unfortunately in our industry today, when someone has worked on a project for 1 year, 3 years, and they've managed 1, 10, 20 servers, they think that they know everything, right? So just like a programmer, after a couple of years, 1 to 2 years, everyone thinks that they're a senior developer, right? Or senior developer is more of a running joke because it takes a lot of time. It takes a lot of time, experience to work on different projects, different things to actually become a really good developer, which means that becoming a developer is really not that easy. There's a lot of things that take to become a good developer, which many one of these things ranges from programming, whether you need to know algorithms, whatever programming language you're working on, libraries, frameworks, even your own editor, right? I mean, there's different people that focus on different things. Personally, I like Vim as my editor. Even as a system administrator, Vim has always been my editor. But I think lots of times as developers or system administrators, we forget about a couple of miscellaneous skills that are very important. One of them, which is communications and attitude. I think that's been something that I kind of heard throughout people's talks today, and especially working on open source projects, communication is very important. As we start to get interested in different projects, we start to contribute, and when we ask for help or we say, hey, I want to do things this way, we end up saying, sometimes we'll get replies of saying, no, that's not it. Instead, us, we should be giving guidance to do things a little bit differently. So if someone, is contributing to a project and they tell you, hey, you should do it this way, even though, they say no, what they really should be saying is, no, that doesn't work for this project because of X, Y, Z reasons, but you should do it this way, or you might want to look at this other alternative that might suit your needs better. Just like any good coder, the only reason I have there, that is beer. I personally love beer, craft beer. I come from Texas. We have a very big microbrewery, so there's a lot of, beers, and I think that's kind of goes in hand. So that's why beers are there. Now, this is from KCD, XKCD, which, this is how to write good code. It really is just a pun because there's really nothing out there that tells you, what good code looks like, what bad code looks like. However, there are a lot of good standards that one should follow, and we should not always be trying to reinvent the wheel, right? We're coming in, there's a lot of things that have been proving that have been done, and they prove that works. And really, just like anything, like from a system administrator point of view, in taking more of a programming or developer role, it's more of changing the way we think about things, right? Lots of times as administrators, when a system is down, the first thing that you do is you want to jump in and fix it, get it up and running, because usually you have angry customers or your boss behind you telling you get it up or is it up every 5 minutes and something like that. So instinctively as administrators, that's the first thing that we want to do. We want to just jump in there, fix it, and whatever it takes, get it done. As a developer, that doesn't really work, right? It's been my experience recently that when I started programming, that's what I would tend to do. I would just want to jump in there and change things and just not really worry too much about what was the ramifications of the things I did, which could end up looking like this. This is just really a call diagram. It shows you the dependencies and stuff like that, which there's better ways to doing it. And it really just means that once you take a step back, right? As the previous talk to here, you mentioned that there should be a contract with APIs, with interfaces. That's really what this means, is that you should really take a look at what you're doing, make sure you're following things semantically. But fortunately for us in Python, there's you could say the Zen of Python, which if you do import this, you get something like this, which is really just telling you a couple of different things that will guide you in, should you lose your way, figure out how or what you should be doing to develop, and some of the things that work. I'm not going to be, due to time constraint, I'm not going to go through all of these 19 things, but I will go and highlight some of them just to kind of show how they've influenced me and and the way my journey to being more of a developer. The first one, it's really more about beautiful is better or simplicity. It really is just about taking things simple and not making them complicated. And that is very important because lots of times we tend to overcomplicate things or want to do things in a fancy way just because we want to show that we learned this new thing, or maybe we found out about list comprehension and now we want to go back and refactor all the code because it's cool. They're cool to make things simple, or in some cases we want to make sure that we're explicit, right? And which is one of those things from the Son of Python, which is being explicit is better than implicit. Compound statements, for example, they're actually pretty simple, right? The example here, the example there, if eggs, for example, print egg, that's okay. Python will interpret it and it will output your data the way you want it. However, the nicer, cleaner way of being explicit would be the second way, right? You just do if eggs, colon, then print egg and spam. It reads a lot better. If someone really, comes and tries to take over your code because you did something, it will be a lot easier for them to read the second statement than try to read one statement which they might just glance at it and not really think about it and go on, and that will trip them for the next 15, 20 minutes because one was not very explicit. That being said, another example of that would be taking advantage of some of the Python built-in libraries, right? So for example, using the with statement. I know personally that when I started doing some of the system administration, I did a lot of Perl, bad me. But then I learned Python, and I started doing things like opening files because I needed to do things, or I needed to, I don't know, for whatever reason I needed to open a file. Using simple statements like the with open statement, right, makes it a lot easier to open files, and it will handle things a little bit nicer than you did, right? That's pretty much another example of how being simple or using some of the Zen of Python to make things a little bit better. Fortunately for me, I've had access to great mentors, which they've taught me different things and pushed me to become a better developer. And one of the things that they taught me was to use list comprehension or comprehensions. They're actually pretty nifty. I did not know about them. So when I started writing Python, my code was pretty much like the top line, which was just for I in range, then do these things, which there's nothing wrong with it. It's it's very valid. But I think as I've matured, using Python and becoming more proficient in it, I started doing more things kind of like the second statement, which is list comprehensions, and you could do it. Not only can you do it for lists, but you could do it for sets. You could do it for dictionaries. So there's a lot of things that you could do with them for those built-in, and will make your code a lot more readable. As I mentioned before, it took me a while for them to stumble onto them because I think as anyone that's trying to program or starting to dabble in programming, we just want to go and start writing things, creating things, and not really care too much about some of the built-in stuff. And it's just really, as I mentioned before, a matter of time. Figuring out and learning what's available to us and how do we take advantage of those things. So as one of the persons that mentored me, he pretty much said to me that programming is, unless you're documenting your code or writing tests, you're really not doing anything more than just hacking. You're hacking. You're not really programming. You're not really being efficient at coding because all you're doing is just hacking things, right? So one of the things that he taught me was to actually get in the habit of documenting things, right? So, which brings me into document strings. Document strings in functions in Python makes things a lot readable, right? They should be used mainly because they describe what your function does, how do you do it without having to read the exact thing of, if you have a function, you really don't need to know exactly or read how it's doing things. You just need to know what inputs it takes and what is the output that you take. And that is the contract, right? That is the contract that, the speaker before me mentioned, that you should be making contracts with your end users so they know exactly how it is that your function is going to work. And, that's how they know it will work, and, it will just move forward. Personally, and with my mentor that I've been working very closely with, he prefers restructured text, which for me, I like it. It works for me. It's the same thing as the one before, just using the three commas for comments. But for me personally, I kind of like that. So when you do docutil, something like that, it renders the code just a little bit nicer. And again, it's more about writing your documentation and then being able to do things that you want to do. Now, one weird thing here is the string up top in the definition function. That's a Python 3.4, if I'm not mistaken, thing, where 3.5, where you could actually start annotating the type of that it's going to return. So in this case, it's going to return a string. And it actually makes it a little more declarative. So it's, personally, I kind of like it. Coming from other languages, it might feel a little more natural. From Python, that looks a little bit weird if you haven't seen it before. Really, at the end of the day, as he mentioned, or it's been ingrained in me, is that unless you're doing testing, you really are not programming. You're not really coding, because there's no way for you to make quick changes and then figure out if things are working, right? So with that being said, one of the best things that you could do is get in the habit of testing, writing tests for your code. And some of those tools are Coverage, Tox, Nose. And for us, we use pretty much Nose with some of the stuff that we do. And this is just an example of Nose running with Coverage in it. And it kind of tells you where you have coverage, where you're missing, some of the things that you should be doing or you should be working to. Right now, this utility has about 90% test coverage, which is pretty good. It's not bad, but we definitely could do a little bit better than that. With that being said, I really don't have that much to say, except that as part of learning to program, just experiment, try different things. Find something that is, that you feel passionate about. So for me, for example, one of the things that I do is I like scuba diving. So in my computer, it actually has a lot of information. So I've actually started taking a look at what information that provides and figure out what I could do with that data. So for me, that is something that works for me, and it's a way for me to experiment with the language, figure out different things, and become a little more proficient. And that's usually the best way that I've seen people that are becoming more programmers or want to go down the programming route. It's find something that they are passionate about and then start doing something with that data. There's some talks today that talked about using government data to do different things, right? So that's something that if you're interested in that type of stuff, there's a lot of different things you could do with that. So with that being said, I really don't have anything much else to share with you except, thank you. And if anyone has any additional questions, please.
Yes. Does anyone have any questions for Victor? I've got a microphone. I can run around and. Okay, excellent.
So did you find that starting life as a systems administrator and within the networking space and then moving into development, that helps you understand more of the full stack? And do you find that is an advantage kind of when you're looking at architecture design over, say, somebody that's just come from a pure computer science background?
So that's kind of tricky, right? Because it depends on what I'm working on. If I'm working on, a system or an application that is a client-server application, yes, it definitely helps me, especially if if I need to figure out how to scale the application. Fortunately or unfortunately, depending on the architecture choices that one makes, that might not be something that we care for, right? So if you use something like Docker or something like that, you really don't care because it's stateless application, and someone else will go ahead and make that scaling for you. You don't have to worry about that. But as far as most of my experience has been around systems integration and scaling systems and making them just work, it definitely has helped me, especially dealing with at the lower levels like TCP, ports. At least it makes my job a little more easier because I know how things work and where they break. So at least troubleshooting becomes a lot easier for me.
Anyone else? No? All right, well, let's give Victor a huge hand.
Thank you.